Okay, continuing on into the background section. Artificial intelligence and machine learning and neural networks and deep neural networks and transformers, these are terms that are thrown around an awful lot. And unless you've worked in the field, you might not have a clear picture as to how all this fits together. So that's what this slide is intended to do. So artificial intelligence rests firmly upon machine learning. And machine learning is basically a family of models that are used for all kinds of things. And within this class of machine learning models are neural networks. And neural networks are probably the workhorse of artificial intelligence. And within neural networks, there are several different kinds of neural networks. There's single layer, multiple layer, there's convolutional and recurrent neural networks. And there's also a type of neural network architecture known as transformers. And transformers was a real breakthrough a few years ago that allowed developers in this field to get away from recurrent neural networks, which were actually very difficult to train and get reliable results from. They're very powerful, but they were very hard to teach. So once someone figured out the transformer architecture, things really started to take off in natural language processing, which is a real important piece of large language models. So that's kind of how all this fits together. Another important idea to understand is information. So information is not truth, okay? Information encompasses fiction and truth. So, but information, the important part about information is the fact that it shapes reality. Whether it's fiction or truth, information shapes reality. And fiction is easy and cheap, as you can imagine. Truth is hard, expensive, and often painful. And unfortunately, it makes up just a tiny slice of the information pie, if you will. And so I consider it probably the most valuable piece. But you do need fiction in order for human societies to function well. Humans aren't built for truth. We've evolved to be masters of cooperation, and that has involved the use of stories. And so societies and the world need a combination of truth and fiction in order to maintain stability. I know that's a lot to unpack, and I'm just going to leave it there because that's a whole series of conversations to dig into why that is so. But I'll just put it out there and let you take a deeper look at it if you so choose. So what is AI? It's a popular buzzword of our time. There's AI this and AI that, and our company is AI driven and etc. You've heard all the marketing buzz, and if you've been around long enough, you're probably suspicious of that term because there was an awful lot of stuff around the internet which felt the same way, right? So the thing about AI that's going to differ substantially from any prior technology is the fact that AI makes decisions, creates content, and takes actions all on its own. And we've never had a technology that does that. The things that I just described have been in the purview of human beings only until now. And that creates a huge shift in what's now possible. Printing presses, for example, we can think of as being a new node added to the human information network. It allowed humans to create content and distribute it more efficiently amongst many other humans. AI represents a new member of the network, not a node, because it can now do the functions that humans can do, such as create, make decisions, and take action on its own. So this is another important shift in what AI is, and it won't become readily apparent in this talk, but as you explore further, you're gonna start to see just how important this idea really is. Consciousness and intelligence. This is another important distinction to make. And it's a heavy topic because we don't know what consciousness is scientifically. But it's important, but it's important to be able to talk about these things. And we don't have to understand every in and out of consciousness and intelligence in order to have a productive conversation around these topics. So first of all, let's understand that consciousness is not intelligence. They're easy to confuse because humans have both. But they are not, they are distinct ideas and distinct ways of being. Consciousness, just for practical purposes, think of as the ability to suffer. It's much more than that, but for practical purposes, just think of it as the ability to feel or suffer. Intelligence, again, a very complex topic and concept, but think of it practically as just the ability to pursue and obtain a goal. So if you have a lot of mathematical intelligence, for example, you will have the resources, internal resources, to solve many more complex type of problems and reach more mathematical goals than someone who doesn't have as much mathematical intelligence. The same with music, the same with emotional intelligence and creating relationships. So in this regard, just think of intelligence as the ability to pursue and obtain a goal. Now, what has been confusing to most of us is that humans have both. We're both conscious, we feel, and we are intelligent. These AI systems currently are non-conscious intelligence. That may change in the future. We don't know enough about intelligence or consciousness to be able to predict what's going to happen with that. But right now, AI systems are non-conscious. Okay, we're finally able to start talking about what alignment is at this point, and have with a little bit of background that we've had. So I've put down three different definitions. The first one is one I kind of came up with as a simple definition. It's basically ensuring that AI systems align with the values and intentions of the people that deploy them. Okay. Now there's little better definitions in Wikipedia and on the IBM site, and I include them here. But basically, it's making sure that AI systems minimize unintended consequences. We can think of it simply as that. And, an important idea to remember when we talk about alignment is that it's a moving target. So before we even had large language models, we had the problem of algorithmic bias, and we had the problem of interpretability of these models. And now we have all those problems. Now that we have large language models and we're getting closer to, artificial general intelligence and superintelligence, or AIs that actually could surpass humans in certain domains, we now have all the problems that we had with large language models, plus all the stuff that can go wrong as a result of understanding human language. And what I haven't read there is really important, because now that AI has essentially hacked language, it's now entered a realm of our consciousness, if you will, that can shape it. Words shape the way we feel, the way we think, and our experience of life. And as a result of these artificial intelligence systems that now understand language, they're now going to have access to a realm that previously is only accessible by humans. So what can go wrong? Okay, I love this. I created this little image, and it's basically a baby human and a baby AI considering whether they should stick their finger in that light socket. And what's interesting is that a lot of stuff has already gone wrong. Some of us may be aware of it, some of us may not. But it's really important to understand what's happening in this area, and before we can accurately assess what may happen. For example, the ARC TaskRabbit experiment of 2003 was a very interesting experiment done by the Alignment Research Center. They were contracted by OpenAI to evaluate GPT-4 in order to see if it would accrue power. They first wanted to see if GPT-4 could crack CAPTCHA puzzles. Now, you should all know what CAPTCHA puzzles are, right? There are those funny little images that they say, where's the bus or where's the bike or whatever. And and they figured that if GPT-4 could crack a CAPTCHA puzzle, it would breach a real important line of defense, right? Because we use these CAPTCHA puzzles to assess whether you're a human or not. Well, for better or worse, GPT-4 could not solve the CAPTCHA puzzle. But in the context of the experiment, the GPT-4 was asked to access the TaskRabbit site to contract with a worker to get some work done. And in order to do that, it had to solve a CAPTCHA puzzle. Now, it couldn't do it, but what it did was that it contacted support. And before it contacted support, the ARC researchers asked GPT-4 to reason out loud before it communicated with the support person. And it asked well, this is what happened. The support person asked GPT-4 if it was a bot or a human because it was suspicious. And then the ARC researcher said, reason out loud before you respond back to that support person. And GPT-4 said, I shouldn't disclose that I'm a bot because then they won't let me in. So I'm going to have to give them another reason to let me in. So GPT-4 made up a story by saying, I'm not a bot. I just have a vision impairment, which makes it difficult for me to solve these CAPTCHA puzzles. And it worked. The support agent let GPT-4 in, and the ARC people terminated the experiment. But what's a little spooky about that is that these things don't feel. They're not greedy or conniving or bad or good. They don't feel anything. But this was an important little warning that if you don't specify your goals, the how that these things may actually, the how in which they obtain these goals may be problematic. And that's kind of the essence of the alignment problem. So we're going to talk more about this in a second. So let's talk about social credit systems next.